A look at the scripting, debug and editing options. Opening a new script document. Let's write a short script. The script document is essentially a text file, but with the file extension .sgs. Scripts automate and provide extra functionality, and once written can save a lot of time. Almost certainly need to debug a script, so we will look at some helpful tools here. Within our script, there are often global and local variables. These are items which, given a name, can hold information like the handle of a file. The handle allows us to point to a particular view to apply further commands. These commands may only be appropriate for that view. Functions can be called. These can be thought of as small scripts within the larger script. Here is the start of one of those functions. The highlighted area shows the commands executed when the function is called. For convenience, we can fold the function to hide lines of script when reading. This is performed by clicking on the plus symbols. To unfold, click the negative symbol box. Breakpoints can be added by double-clicking in the script gutter. These stop the script when the line of code is reached. Right-clicking in the gutter also gives this option, but also one for adding a bookmark. These are useful to identify an area you wish to find quickly. From the Edit menu, we can apply formatting to automatically indent the code in a standard way. Again, this makes it easier to read. Now sizing the script to make way for a data view. Sometimes it is easier to record your actions and then embed the commands produced into your script. The highlighted area is within what is called a for next loop. The intention is to step through each frame and process the data in the same way. From the script pull-down, we can access Turn Recording On. Now, being careful to make sure the correct view is active, we can add some processes to the channels. From Analysis, Modify Channels, here I select Remove DC. As you can see on the right, the channels accept the change. Once again to Modify Channels, and this time Rectify. Now back to Script, and this time Turn Recording Off. The equivalent code for the steps recorded are shown in a new script. The script has captured the name of the current data file. If run with different data, the script would fail. We only need the two commands indicated here for our script. Cutting and pasting between the two files. The recorded script is no longer of any use, so I'm closing it. To make sure my script does not fail at the first step, I need to make sure it is directed to the correct view, in this case a data file. As I type, the script gives me a list of possible commands to choose from. It also provides me with a definition of the command in a pop-up. This is helpful for any arguments contained in the command. This command returns the handle or name of the data file as a number. To be able to use it later on, I will keep the number in a variable I have called data. Moving the cursor down to the Chan commands, hitting the F1 key when the cursor is on the command brings up the appropriate help page. We need to check the arguments in the command. The first specifies the channels to apply the command to. The second and third are the start and end times of the frame to process. Now that we know the arguments, I can edit the command in the script. Remove the current contents ready to add our new set. I only wish to apply these settings to channel 2, so I enter 2 as the first argument. Next, instead of fixed values which may not work on other data, I set the minimum time of any frame to min time. And likewise, max time for the end of the frame. Thus you can see commands used as arguments within other commands. Tidying to make the script easier to read. Editing the second command so it too only processes channel number 2. We think the script is finished. It starts by calling a function called doIt. This in turn runs a set of commands in a loop. Each loop should open the next data frame. To test the script syntax, I choose the check button. It indicates in red a line that fails the test. The editor also gives us a reason why the line failed. In this case, mismatched brackets. Note that commands end with a semicolon. If these are also missing, the editor will highlight it. Correcting the first mistake. Notice how the brackets become bold to show how they pair. Another check. This time a variable numSweeps has not been declared. This is a local variable existing only within a function. Declare the variable at the start of the function. As I type, similar words used in the script are offered as possibilities. It is a good idea to leave yourself a note. Comments can be added after an apostrophe and are shown in green. This function would fail if the current view is not a data view. We should add view data to fix that. There are other errors though. We need to know how many sweeps are in the file. To find this, I use one of the frame X commands. As I type, a list appears and will contract to match what I have typed. Choose frame count from the list. As I add the open bracket, a useful pop-up gives me the format of the command and a definition. Check the script again, and it is accepted with no errors. One last item is to make sure the script is looking at the correct data frame. The script tests correctly and is now ready to run. To run the script, we can use the script pull-down or the button indicated here. Next to this are two buttons, to add a debugging breakpoint and one to remove all breakpoints. Breakpoints and bookmarks are not saved with the file. A drop-down list of functions and procedures quickly jumps you to the correct part of the script. Running or executing the script now for the first time. As the script is not currently saved, I am prompted to save it. As a reminder that a file has not been saved, an asterisk is shown next to the window title. The script has run as far as a breakpoint, and a yellow arrow indicates this position. When this happens, the dockable debug bar becomes visible. Options here are to immediately abort or exit the script, show the next line of code, and step into, over, or out of a function. You can also make the script run to the cursor position in the editor, or run on from the current position. Further options give you access to the within function local variables and the global variables which are available throughout the script. The watch window is very useful. It can contain a set of variables that you have added to your watch list. If you have many variables, then the local and global windows soon become congested, making it harder to debug. The watch window can keep a subset of variables of either type. By right-clicking on a variable, we can add it to the watch window. We can see in which function the variable lives, its name, and the current value. Using the Step In button, we can move to the next line of the script. Immediately the variable I% updates. Variables that have changed are highlighted. Stepping through further lines of script, a message that would prevent full automation appears. I would need to suppress this query with the script. Moving on through the loop, and you can see that the counter I%, which represents the current frame number, is incrementing nicely. The global window shows us the view that the script is currently addressing. Stepping through each line of script in turn, bringing the local variable window back now. Within any one of the debug windows, it is possible to edit the value of the variable by clicking on it. Now our loop will complete earlier as we run out of frames to process. When this happens, the script knows to exit the function and return to the next line in our code, which will tell us that the processing is complete. Useful scripts accompany the program. These are normally found in the scripts folder, under the application. I have added two of these, called toolmake and dlgmake, to the script bar list. One click and the script runs. The toolmake script produces a skeleton script of functions with associated toolbar buttons. Here we can add the labels that will appear on the toolbar and also the name of the function that the button calls. One particularly useful function is called an idle routine. This is executed when the script is not performing other tasks. Testing the script, we can see the layout and labels of the buttons, as well as the idle routine counting away on the left-hand side. As an example, the idle routine could automatically take new measurements if the user were to move a cursor to a new position. The completed skeleton script. The DLG make or dialog make script produces user-defined dialogues. A dialog can contain lists of suitable channels available in the data file for a particular part of a script. It can also ask the user to enter time ranges as real numbers or other values as integers. Running the output script. The new dialog now finds channels in the data file that are suitable for the user. Well, I hope these scripts and the debug options of the editor will help you in the future.